Hello everybody, and welcome to the next video of the course. In this video we will cover our next foundational topic or tool in Python. The topic is loops. It is impossible for me to tell you how powerful these are and how useful these are in programming in an introductory video. So today we're just going to see what they are and just get comfortable with the syntax. However, loops are extremely powerful. Real program is absolutely impossible without them. This is a foundational topic. We will be using them extensively throughout the rest of the course. So what we're starting today is very important in this video, but this is just an introduction. We're actually going to spend 3 full class days just on loops before moving on to other things and then incorporating loops into other things. But anyway, this is a foundational topic in the same way that things like if statements are foundational. So today the goal is fairly simple, just to motivate the idea of a loop, like why you would need them, and then introduce you to some basic examples. So the examples that we will get to by the end of the course will be much more sophisticated and complicated than what are in this video. So let's start with the motivation. So let's think about why a loop might be useful. So sometimes, or most of the time actually, in most programs you might write, once you are writing more sophisticated programs, you might need to repeat a chunk of code. So what does that look like? What's an example of that? Well, suppose you've written a program that lets a user enter a bunch of homework scores, and then what your program does for them is calculate an average, a homework average. And maybe you're calculating an average like in some of your courses where you drop the 2 lowest scores or something. Whatever, you're computing some sort of homework average. And in order to do that, you have to build a way for people to hand you their first score, their second homework score, and so on. So how might you do that? Well, this here is sort of pseudo-Python. It's just a schematic. But first of all, before they've given you anything, you can create an empty list of homework scores. There's nothing in there right now because we haven't been given anything yet. And then, as long as the user wants to keep handing you a score, right? They're not done giving you scores. What should you do? You should let them hand you that individual score, and then you can use this append function from the previous video to throw that score into this list. So you can just keep creating this list as the user keeps handing you more and more scores. So initially there's no scores. Then they hand you a score, right? So the value of this variable becomes whatever their first homework score is, and then that gets put inside this list. And then you want to just keep running the same 2 lines of code over and over again until the user runs out of homework scores. So if they have 12 homework scores, you would want to run these 2 lines of code over and over again, 12 times. So that's the idea of a loop. Other examples are, suppose you've written code that lets a user play chess, and once the game is over, you might want to let them play again, right? So you can ask them, do you want to do this thing again? And if they say yes, you just want to run that chess code again, And if they say yes again after that game, run the same code. So that's the idea of a loop. If you want to run, in this case, these 2 lines of code over and over again, you can do it. There are 2 types of loop in Python, a while loop and a for loop. We're going to spend 2 days on while loops, and then the 3rd day we will move to for loops. So here's the syntax of a while loop. So you write while, and then you have to have a Boolean expression here, an expression that can be either true or false. And then inside the while, you have it indented, just like you do for an if statement. You put some code that you would like to run over and over again, some code that you would like to repeat. As long as this Boolean expression here is true, what Python will do is it will run this code, and then when it gets to the end of the code, it will check and see if this expression is still true or not. If that expression is still true, it will just run this code again, and then get to the end of the code, and then check, is this expression true or not? And if it is, runs the code again, and so on. Okay, so all that to say, the English word if translates to if in Python, nicely enough. The English phrase as long as, or sometimes you might see the word until used here, but as long as you want something done, that translates to while in Python. So if you're translating Python code to English in your head, whenever you see a while, you should translate it to as long as. Okay, so let me just show you an example. These become much more comfortable or much more approachable if you just have an example. So here's just a little snippet of Python code. First, x equals 5. And now, in English, as long as x is bigger than 1, colon, do something. Right? These are commands here, you know. What do I want the program to do? I want it to print x. And then what do I want it to do? I want it to take the old value of x here, take 1 off of it, and that's now the new value of x. Okay, so for example, let's just talk it out when x is 5. X equals 5. 5 is indeed bigger than 1. So x bigger than 1 is a true statement. So now I'm supposed to print x. Well, x is 5, so I'm going to print 5. And now x becomes x minus 1. So x becomes 4. It has value 4. Okay, then when Python gets right here to the end of whatever code is inside the loop, what Python does is it jumps back up to this right here. Okay, so as I said in sort of the opening video, Python usually reads from top to bottom, but there are exceptions, and a loop is an exception. It can let the program jump back up to the top of some code segment. So it jumps back up here, and it just checks, is this condition still true? And if it is still true, it just runs this same code again. Well, 4 is bigger than 1, so I run this code again. Now, x has value 4, so I print the 4, and then I do the same sort of subtraction thing here. 4 minus 1 is 3, so the new value of x is 3, and so on. Okay, so eventually I get down to an x value of 2. Right, I keep taking 1 off of x. 2 is bigger than 1, so I will print 2. And now when I do this replacement here, 2 minus 1 is 1. So x has value 1. Well, if x has value 1, this statement is now false because 1 is not greater than 1. So then the program terminates. Or sorry, this loop terminates. It's done. So it prints these 4 values. X is 5 and it prints it. X then becomes 4 and it prints it. X becomes 3 and it prints it. X becomes 2 and it prints it. But then x becomes 1. This statement is now false, and now the loop is done, and the program will move on. So now the cursor comes like right here. The program just keep moving. So just as an aside here, this command x equals x minus 1, you can shorten it if you want to. X plus equal negative 1, that just peels 1 off of x. Similarly, x equals x plus 1 can be shortened to this, x plus equal 1. If you like, you don't have to. In general, if you want to add 3 to x or something, you can just write x plus equal 3. Okay, so when you're first dealing with loops, if I were you, you don't have to do this, but if I were you, I would draw a little table that maps out what the loop is doing at every single step. So all the English I said in the last slide, you can just write it out in a table. So in this case, this loop runs on what the value of x is. So I have one column here that says what the value of x is at a given time, and then I say, well, what happens in the loop when x has that value? So when x is 5, I print 5 because x is 5. I'm printing x. And this line of code here changes the value from 5 to 4, and so on. So when you're first getting used to loops, I would strongly suggest you make, this is sort of scratch work if you like. You know, you can just sort of draw out what the loop is doing. So let me hop over to the compiler where I have this loop preloaded. So let me just first run it and make sure it does what I said, 5432. That's what it does, right? Let me just fiddle with this a little bit, and you should fiddle with it too. Inside the loop, you can make it do whatever you want, you know. So I put this extra print high command in here. So now what happens? When x is 5, 5 is bigger than 1, that's true. So I tell it, print 5, then print high, then take 1 off of x. So now x has value 4. So now it hops back up. 4 is bigger than 1, that's fine. So now it prints 4, it prints high again, and so on. So you can put whatever you want inside of these loops, with some exceptions where you have to be careful. But in general, you can just put as much code as you want in here and have it do whatever you want. I'm not sure why you would want it to tell you high every time the loop runs through, but again, you can do whatever. You could have it print x plus 3 instead of just x. Let's watch that. X is 5. 5 is bigger than 1, that's true. So it goes into the loop. Well, now you're telling it to print x plus 3, which is 8, and then print high, and then take 1 off the value of x. Well, x still has value 5, right? You didn't change the value of x here. You just ask it to print 3 more than x. So x has value 5, so now x takes on value 4, so now it will print 4 plus 3, which is 7, and so on. That's the idea of a loop. You can also, by the way, put whatever Boolean statement you want here. So for example, consider something like this, x less than 10. Let me change this back. Okay, so now x equals 5. As long as x is less than 10, it will do this stuff in the loop. So let me now make x increase by 1. Okay, so x has value 5, I print high, right there. Then I increase x by 1. So now it's 6. 6 is less than 10, so it prints 6. 6 becomes 7, 7 becomes 8, 8 becomes 9, and then finally x becomes 10, and this statement becomes false, so now I'm done. So now if I do some stuff later, print 30 or something. So when the loop terminates, Python's cursor is right here at line 14. There's nothing there, so we'll move on to line 15. And so notice there's just a 30 at the end now. So the program just moves on once the loop is done. Okay, so again, if I were you, I would draw these little schematics of what a loop is doing when you're first getting used to them. But the core idea is just you keep running this code over and over again as long as this condition here is still true. Okay, here's another example. So suppose you want to write a friendly program where it just lets a user tell you how many times they want to greet you. So get a number from them. How many times do you want me to greet you? Okay, so let's do that. Come back over to the compiler, clear this out. Okay, so number equals input. Sorry, I can't type input. Okay. My text here is large, so rather than letting it run off the side of the screen, I'm just going to ask them how many times. Okay, so I've grabbed a number from them. How many times should I greet them? And now, as long as number is bigger than 0, and presumably they give you a number bigger than 0 first, you know, if they want to be greeted, say 10 times or something, I'm going to print hello there, and then I'm going to decrease that number by 1. So again, if I were you, I'd get pen and paper out and think about what's going to happen when I run this. Okay, so first of all, I'm going to grab from the user how many times to run. So let's just say 4. Once I hit enter, that 4 is going to be entered as the number, and this loop is going to run, or potentially run. So let's just think about what's going to happen. 4 is bigger than 0. That's true, so it prints hello there. And then what happens to 4? It gets knocked down to 3. Well, 3 is bigger than 0, so it's going to print hello. 3 gets knocked down to 2, and so on. It will terminate when number becomes 0, right? Because 0 is not bigger than 0. Whoops. Enter. Okay. So notice it printed hello there 4 times. Notice if I set this loop up a little differently. What if I put number bigger than 2 there? Okay, so how many times? What if I put a 4 in now? What should happen? Well, number still becomes 4. 4 is bigger than 2, so it prints hello there. 4 gets knocked down to 3. 3 is bigger than 2, so it prints hello there. Then number gets knocked down to 2, and suddenly the statement's not true anymore, so it will stop. So I set up a loop that didn't run enough times. I wanted it to greet me 4 times, not 2 times. So anyway, that 0 there is not arbitrary. It makes the loop run as many times as I want. Okay, so there's another, just an example of a loop where you can grab information from the user that determines how many times the loop runs. Let's return back to that opening example of getting homework scores from somebody. So as I had in the schematic, you start with just an empty list of homework scores because they haven't given you any yet. And now you can give them a message like this. Enter as many homework scores as you want, like just do 5, enter, 10, enter, whatever your homework scale is, right? Enter a negative number when you're done. Okay, so how does this work? Well, there are lots of ways you can get a loop to run that does what you want here, but notice what I've done. I've set up a dummy variable x. It exists only to control how the loop is running. And initially x is 0, so this statement is true here. X does indeed equal 0. And then once you go inside the loop, what does it say to do? You grab a number from the user. They give you a score. If that score number they gave you is 0 or bigger, you're going to throw that number into the homework scores list using the append function. Otherwise though, right, what if it gave you a negative number? Then you change the value of x to 1, and suddenly this statement's not true anymore. So the loop will terminate. So I have this loaded in my compiler somewhere else. Let me see. Okay. So homework scores is empty. Enter as many scores as you want, blah, blah. Enter a negative number. Now, as long as x is 0, this loop will run. And what does the loop do? It grabs a number from the user, and then it throws it into that list. So what I'm going to do extra here, once that loop is done, I just want to check and make sure it recorded all the scores I gave. So I'm going to have it print homework scores. So initially, that's an empty list. Presumably after the loop, it's not empty anymore because you've populated it with scores. Okay, so blah, blah. Enter blah as many as you want. So I'm going to enter, let's say we're graded out of 10 here, right? So I do really good. I get a 10, I get an 8. Notice it just lets me keep going, right? Why does it let me keep going? Because every number I'm typing is 0 or bigger. Even if I type a 0. Keeps going, right? But just keeps letting me put scores in there. 5, 5. Finally, let's say I'm done. I'm going to type a -1. Okay, notice the loop is done, and what does it do? It prints the list that I created. Okay, isn't that nice? So you can create lists via a loop, and you can let the user create a list via a loop if you want to. Okay, so here you go. You just let the user create a list of homework scores. So to keep this video a reasonable length, we're not going to do much with this, but in the next video, we'll start messing with this list. Like, I mean, once you have their scores, what do you want to do? You want to create an average? Do you want to calculate the median of their homework scores or whatever, you know? Okay, but here's an example of grabbing information from a user and creating a list out of it. Okay, here's the same example, but here's another way you can do it. I just want to use this example to introduce the idea of a break statement. That's the point of this. Notice it starts the same. Homework scores is empty, blah, blah. Enter as many scores as you want. Negative number is how you know you're done. Notice this I've written here, while true. Okay, true is actually a reserved word in Python. Python knows what that is. True as a word just means literally true. So remember, you have to put a Boolean expression there. I've put the Boolean expression true right there. Okay, so that expression is just true by default. It's true by definition. So I will go inside this loop. So notice this is the same command. You can grab a score from them. If the number is 0 or bigger, I'm going to throw it into that list. But notice this statement here. Otherwise, what if they give me a negative number? What I put now is this word break. Break is a Python word, and what it does is, whenever you encounter a break statement inside of a loop, and this break statement is inside this loop, the loop will just stop running. Okay, it breaks the loop, or it breaks you out of the loop, if you like. So anyway, this loop structure here does the same thing. You go into the loop because you have a true statement right there. You grab scores from them. As long as those scores are positive, you record them and put them in that list. But if the user gives you a negative score, break. And now you're out of the loop, and you can keep going on with the program. Okay, let me just show you one more example, and we'll be done with this intro video to loops. So suppose you ask the user whether they want to play a game on hard or easy mode. So you say, hey, enter E for easy, H for hard. Well, the user might mistype. You know, they might type a T or a D or whatever. And you should let them re-enter their answer. And we've already seen code that does that. We've had this basically exact same code before, but there was an if right here. If their answer wasn't E, and it also wasn't H, then make them try again. You know, we've seen this before. So how is this any different from before? Suppose you have an if right there, right? If they type something invalid, make them try again. What if, once again, they mistype? Okay? They make a second error because they're really clumsy on their keyboard. If you have an if statement right there, it lets them retry once, and then the program just moves on. Okay? If statements don't let you repeat code. A loop, though, will let you repeat this code. So suppose they've already messed up, right? They've already entered a T or something. Now you go into the loop, and you tell them that's invalid, try again, and now you grab an answer from them again. Well, what if they type a T again? Well, T is still invalid. So Python checks, is this still true up here, right? Have they still entered something invalid? And they have. So it'll repeat this code. Suppose they type a T again. Again, Python checks. Oh, that's still bad. That's still wrong. So it'll force them to do it again. So loops will show up all the time in code that grabs information from people like this, easy or hard, 1 or 2, whatever. And they'll show up to make sure that the user enters something valid. So you can just keep prompting them for correct, valid answers as long as they keep typing something invalid. Okay, so before we terminate this video, let me just issue a warning here. You have to beware of what are called infinite loops. So this structure right here, this example, we've already done it before, but notice there's a line of code missing right here. What's missing is this x plus equal -1 command, so making x smaller. Okay, so let me put that back in here. So x equals 5, as long as x is bigger than 1, print x, and then before I had a command like this, right? Well, the example on the slide was missing this line 12, so let me get rid of it. Let me run this and show you what it does. It just prints 5, 5, 5. It's just still printing 5s, 5, 5, 5. So I'm going to have to stop it from running, or eventually my computer will run out of memory. That it just kept printing 5s. So see if I'm scrolling. See all those 5s are printed? It would have kept printing 5 forever, or until my computer crashed, Now, why is that? Why would it keep printing 5s? Well, if you read this code here, right, x is 5. 5 is indeed bigger than 1. So I print that 5, and then the loop is over in terms of what the code here, right? So what Python does is it jumps back up to this and checks if that x bigger than 1 condition is still true. And it is, because x is still 5. So it prints 5. Then it jumps back up. 5 is still bigger than 1. Prints 5. Jumps back up. 5 bigger than 1. There's no change to the x value inside this loop. So this statement is always true. So there's no way for this loop to terminate. Okay, same thing, by the way, if you did this. What if you did this? X equals x plus 1. Okay, well, x is 5. 5 bigger than 1, that's fine. Prints 5. X now becomes 6. You increase x by 1. 6 is bigger than 1, so you print 6. X becomes 7. 7 is bigger than 1, and so on. So it just keeps getting bigger and bigger. It'll run forever if I don't tell it to stop. Right, so it got all the way up to 23,285 before I stopped it. Okay, these are called infinite loops, loops that run forever. They are bad, and you shouldn't have them. Okay, if you have an infinite loop, if you have a loop that even in principle cannot be broken out of, can't be terminated, that's bad. Okay, so creating infinite loops is a common first error for people who aren't comfortable with them. But just know that when your screen starts freaking out, it starts printing things over and over and over again or whatever, that just means that you probably have not changed the value of the variable or something that keeps the loop running. You've stumbled into an infinite loop. So you're going to have to go back and add code to get yourself out of it. In this case, that command would be something like x equals x minus 1 or x equals x minus 2 or whatever. Like somehow you have to be decreasing the value of x so that eventually this condition is broken. So you break out of the loop. Okay, so at the end of this video, hopefully you're comfortable with these first examples I've shown you. You're comfortable with the idea of a loop, which is a chunk of code that runs over and over and over again as long as some condition is satisfied. And as soon as you break that condition, you are out of there.